Good morning, children. Today, we'll prove a number, the given number, is irrational. Okay? Rational and irrational. Till rational we learned, now we are learning the given number is irrational number. Suppose the question is, show that root 2 is irrational. That means root 2 is a irrational number. So how to prove it is as irrational number? Okay, if you find this root by using long division method, you will get 1.4142, so on, something will come. It never ends, never repeats, non-terminating, non-repeating decimal it is. So, how to prove this is as rational? So, this type of problems we will go with contradiction method. What is that? Contradiction method. That is, the statement what is given will take in opposite way. That means, I am taking let root 2 is a rational number. Root 2 is rational number. I am using let. That means my assumption. I am assuming root 2 is a rational number. As per the rational number, the condition is rational number is in the form of P by Q, where Q is not equal to 0. HCF of P comma Q is 1. And this is very statement here. That is HCF of P comma Q is 1. HCF of P comma Q is 1. That means there is no other table will be cancelling or divisible among P and Q other than 1. Now root is there. To avoid root or to eliminate root, what I am doing? Squaring on both sides. So root 2 whole square is equal to P by Q whole square. Square root cancel, 2 is equal to P square by Q square. Therefore, P square is equal to 2Q square. After cross multiplication, I got P square is equal to 2Q square. I consider this PQ is equal to 2Q square as equation 1. Okay. From this step, what we can say? Right. P square is a multiple of 2. P square is multiple of 2. Therefore, P is multiple of 2. P is multiple of 2. And consider this is as second equation. Okay, P is multiple of 2. What is meant by P? A 2 multiple. So that can be written as P is equal to 2 multiple. P is equal to 2 multiple. Now, P is equal to 2 multiple. Now, I am doing squaring on both sides again. Okay, squaring on both sides. So, P square is equal to 2m whole square. So, here P square is there. See here, P square is there. P square is equal to 2Q square. We have already. P square is equal to 2Q square. I'll substitute this one there. Okay. So, instead of P square, I am writing 2Q square, 2m whole square. 2 into 2, m square. Since from first equation I substituted P square is equal to 2Q square. Now, may I cancel 2 and 2? Alright. Now, Q square is equal to 2m square. Therefore, Q square is multiple of 2. Q square is multiple of 2. That is, Q is multiple of 2. Q is multiple of 2. Now, I am considering this is as third equation. This is as third equation. So, from second and third, second and third equations, what we got? Second equation, P is the multiple of 2. That means P is divisible by 2. P is multiple of 2. Means P is divisible by 2. Here, Q is multiple of 2. That means Q is divisible by 2. That means from 2 and 3, HCF of P comma Q is 2. Not 1. Okay, why I wrote not 1? It's a question. Why I wrote not 1? See here, the first my assumption, let root 2 is rational. As per the rational number P by Q, then HCF of P comma Q should be 1. But what I got, HCF of P comma Q is 2. So what my assumption is wrong. So our assumption is wrong. What is your assumption? Root 2 is not equal to P by Q. So root 2 is not a rational number. Root 2 is not a rational number. So what? If it is not a rational number, so what? Root 2 is a irrational number. Root 2 is a irrational number. So, if it is not a rational number, then it is a irrational number. We assumed it is as rational number. In contradiction way, we proved it is as a rational number. Okay? Now, we will do one more sum. Root 2 is completed. Now, next sum. Show that. Oh, I did not give any question, right? Any number. In that place, you can write 3, 5, 7, 8, 11, 13, whatever number you can take, you can take. Procedure is unique. A single procedure. Whatever number you want to take, you take. Let example I am taking. Suppose show that root 7 is irrational. What is that? Root 7 is irrational. Now, root 7 value, some 2 point will come, so on. Now, let root 7 is a rational number, I will take contradiction method. Then that is root 7 is equal to P by Q, where Q not equal to 0, HCF should be 1. Now, squaring on both sides, root 7 whole square, square root cancelled, 7 is equal to P square by Q square. Here denominator Q square come to this side multiplication. P square is equal to 7Q square. Consider this is as equation 1. What is that? P square is equal to 7Q square. Equation 1. Therefore, P square is a multiple of 7. Then P square is multiple of 7. Automatically, P is multiple of 7. Okay, what is that? P is multiple of 7. Then P is equal to 7 multiple. P is equal to 7 multiple. Now, 7 multiple, that means P is equal to, it's a 7 multiple. Then P is equal to 7m. So, squaring on both sides, P square is equal to 7m whole square. P square value is equal to 7Q square. So 7 into 7. Both 7s are cancelled. 7m square. So Q square is multiple of 7. So Q is multiple of 7. So P is multiple of 7. Q is multiple of 7. That means HCF of P comma Q is 7. Not 1. So my assumption is wrong. That is root 7 is not equal to P by Q. So root 7 is not a rational number. Therefore, root 7 is irrational number. Root 7 is irrational number. Like this, you can write any of the number to prove it. This is as irrational. Okay? Now, one more example. Show that 2 plus 3 root 7 is irrational. Okay, 2 is an integer, 3 root 7 is an irrational number. Now, sum of rational and irrational together is irrational. We need to prove. Then how to prove? Okay, for a time being I am leaving like this. What is that? Let 2 plus 3 root 7 is rational. Okay, that means A belongs to a rational number I am taking. So 2 plus 3 root 7 is rational I am taking. So 2 plus 3 root 7 is equal to A. So 3 root 7 is equal to plus 2 transform minus 2 root 7 A minus 2 by 3. So if A is rational, then A minus 2 by 3 is also rational. What is that? If A is rational, because it is given A is rational, if A is rational number, then A minus 2 by 3 should be also rational number. So A minus 2 by 3 is a rational number. This is a rational number. Then what about this? Irrational. But we need to prove. I am taking this is also, let root 7 is a rational number. I am taking P by Q form, squaring on both sides. P square is multiple of 7. Then P is multiple of 7. Then P is equal to 7 multiple. Okay. P square, squaring on both sides. Then Q square is 7 multiple. Q is 7 multiple. HCF of P comma Q is 7. But not 1. Therefore it is irrational. So what we got? Root 7 is irrational. So now at the end what we got there? Root 7 is equal to A minus 2 by 3 we got, where root 7 is irrational. See, this is irrational and it is rational. How this is possible? Rational can be irrational? No. So therefore what we can write? Root 7 is not equal to A minus 2 by 3. That means our assumption is wrong. Here our assumption is wrong. Therefore root 7 is not equal to A minus 2 by 3. Then by 3 go to this side into 3 root 7 is not equal to A minus 2. Minus 2 transfer plus 2. 2 plus 3 root 7 is not equal to A. What is not equal to A? A is rational number. So 2 plus 3 root 7 is not a rational number. 2 plus 3 root 7 is not a rational number. Not a rational number. So what? Therefore 2 plus 3 root 7 is a irrational number. Is a irrational number. So this is the way, if it is given like a combination of rational and irrational, this is the way to prove a rational number or irrational number. Okay?